All right, the sooner we get started, the sooner we can get things going. Welcome today to General Engineering in your first week of EG 1003. For those of you who don't have me in recitation, my name is Jack Bringardner. I'm a professor in the General Engineering program. Today is to kind of round out what you've learned from if you've had lab or what you've done in recitation. For those of you who have lab tomorrow, we'll give you a quick preview of what you're going to be doing tomorrow. But the main gist of today is to understand what you're going to be doing this whole semester in this course and what the purpose of each of the sections of the course are. After I present, we have Kaylee Dunnigan, who is a senior head TA in the Research and Development Group, who's going to present on one of the project opportunities that you have, the Rapid Assembly and Design Challenge. This is something that we showed you at Convocation. We had that short video about some of the types of projects that you can get involved in. So, one thing that I want you to do right now is put your laptops away. You don't need those for this lecture. And please stay off your phones, as well as be quiet throughout the entire lecture. All right, so like I said, the main thing today is going over EG 1003, just a quick discussion of the course, and understanding how EG 1003 relates to the engineering profession and just technical professions in general. So, what is EG 1003? The purpose of this course in first year engineering is to introduce you to these main topics: the engineering disciplines, some of the professional tools and resources you're going to be using. We want to give you enough of the terminology and definitions that you'll need so that when you go on into your second semester and second year courses, you're familiar and comfortable enough with learning the new materials. There's a big emphasis on design and teamwork, and I'll show you in a minute when we go over the labs. There's going to be a number of active and hands-on engaging activities in the labs that you're going to be working on. And then a big emphasis on communication and your ability to communicate your ideas as well as technical information. These last three are associated with your projects. So in this course, there's a lot to do. There's lab reports every week, there's presentations every week, and in addition to that, you're going to be working on a project. This is to simulate the real-world work environment where you're going to have to manage your time wisely. But you're also going to have to think about other project management aspects, like the budget that you're using, your overall schedule to accomplish the tasks, and then the business aspects of it. How are you going to sell your idea to potential investors, people that you're going to be working with? The structure of this overall course, there are 21 sections. 3 sections run concurrently in each of the labs. So 7 sections of different timing, and everybody in those sections, like the A1, A2, A3 section, all have the same time schedules for labs, recitations, and of course everyone's in here for lecture. The TAs in this course are made up of second, third, and fourth year students who passed this course successfully and enjoyed it enough that they want to come back and then hopefully give you that good experience. You also, in recitation, have technical faculty as well as writing consultants. The technical faculty are there for the recitation primarily to give you feedback on your technical communication, and the writing consultants are there to help you with your lab reports. As well as those faculty are there to just guide you through the course the entire semester. And then in this lecture, we're going to have a variety of invited speakers, some people from departments here at Tandem, as well as people that are from industry to talk about what they do and how it impacts engineering. I'll give you a little bit of insight into that in just a second. But how this really works, it's different than typical courses. Your primary point of contact is going to be the teaching assistants, your recitation TAs, as well as your lab TAs. Use the TAs as a resource for this course. Like I said, they've all passed it, so they know what it takes to get through the course, get through all of the assignments as well as the project successfully. They also know a lot about Tandem, because they are either going through it right now or just went through the things you're about to go through. So talk to them about everything that you want to talk about and use them as a mentor and a resource for your time here at Tandem. Obviously, the reports and the presentations will be graded. The goal is to give you feedback, and one of the themes, hopefully, of this lecture is that this feedback is to help you improve these actual skills that you'll use in the real world, but also to help you improve throughout the semester so you understand what our expectations are. So you'll be informed of your progress throughout the term, through the recitation professors, the writing consultants, as well as the TAs who are your contacts for any issues related to grading or any concerns you have about your performance in the class. The labs are JAB 574, 576, and 577. For those of you who've been in lab, you already know where these are. This is in the extension of Rogers Hall, which is Jacobs Academic Building. On the 5th floor, there are 3 smaller EG labs for the regular lab sessions, and then the large lab, the model shop, in JAB 573. This is where you'll go next week in recitation as you're deciding the teams and the projects that you're going to be working on. And in there, you're going to be working on your projects throughout the entire semester. TAs are available in Rogers Hall 515A if you ever need to get a hold of someone for something specific about the course. But again, email put through your recitation TA is the best way to contact someone and get an immediate response. The website and the lab manual, you've hopefully gone over in recitation and lab, are eg.poly.edu, and that is a typo, it's manual.eg.poly.edu for the online lab manual. The open lab times will be posted. That's when the model shop JAB 573 will be available for you to work on the projects, as well as if you need to do any kind of makeup lab assignments. And I just want to reiterate what you've already heard about academic honesty in recitation. The plagiarism policy in this course is taken very seriously. Don't run into this issue this semester, otherwise you'll receive the 0 penalty for the first time that it occurs, and then the next time it is an F in the course. So everybody's very clear on, we're strict on the fact that you need to be submitting your own work, so the feedback that we give you can be taken into account when we move on and improve throughout the semester. In addition to the model shop, we also have the prototyping lab, some of which will have some of the materials in the model shop as well. The prototyping lab is in between labs 1 and 2. And this is a resource for you. We encourage you to use the makerspace, but sometimes the makerspace is a little bit daunting. There's a lot of equipment in there. Some of it requires significant training, and there's senior design projects as well as graduate research going on in there. So this is a place for you to get some one-on-one instruction on things that you might not be comfortable with yet, including soldering or 3D printing. This semester, you are going to be required to do 1 3D print. We want everybody to have the experience as a team to go through designing and building something in 3D modeling software and then printing that out. And then you have the option of printing additional items for extra credit. I highly encourage you to get involved in this. It also adds another dimension to all the projects and allows you to be a little bit more innovative with what you're doing. We also have a series of workshops, so be on the lookout for an announcement to be posted on the website about the dates and how to sign up for these. These are to support people that are interested in these areas, as well as projects that require these specific skills. So if you're interested in Arduino or soldering or learning how to use a Raspberry Pi, I encourage you to attend these. They'll be held in the makerspace, and our TAs will be leading them. And you have the chance to learn a little bit outside of what the traditional curriculum in EG 1003 is. So the traditional curriculum is made up of lectures, labs, recitations, and the semester projects. Like you've seen this in recitation. These are the hours associated with these each week, and then the workshops are those new optional additional chances to learn more skills. So to break this down, lecture, you're in this today, 12:30 to 1:50. We open up at 12:30 to let you all funnel in. You can see this is a very large class, so it takes a little bit of time to take attendance, get everybody in their seat. Lecture will start promptly at 12:45 and we'll finish up around 1:40, 1:45. So that additional buffer time is really for us getting in and out of Pfizer Auditorium. But expect that lecture to last about an hour. That 5-minute mark that was mentioned in recitation is at 12:50. So at 12:45, we expect you to be in your seat. Past 12:50, you won't get credit for the lecture. And don't forget that this is 1% of your grade for each lecture, so make sure you get in here on time. We will focus on a number of professional skills, things about the engineering profession in general, and it'll be a mixture of people, faculty at Tandem, as well as guests. So this is the planned lecture schedule. This is tentative and subject to change based on availability. But the next 3 weeks will be focusing on some of the core professional skills that you'll need for the project this semester, project management and teamwork. In the third lecture, we'll actually have a group of teaching assistants come in here and act out a good way to act throughout the semester as a team and a poor way to act throughout the semester as a team. Then we have people from the civil, chemical, and electrical engineering departments. Somebody from industry, a colleague of one of our faculty members, is coming to talk about artificial intelligence and how we have to deal with bias as artificial intelligence is deployed in a variety of sectors of industry. One of the deans is the head of the cybersecurity group, who will come in and talk about how to add security to software. And then one of the robotics gurus will come in and talk about mechanical engineering, robotics, and then a little bit more on the future of technology. Finishing out with somebody from industry who's going to come talk about the World Trade Center rebuild project. So it's a multidisciplinary project looking at how we redevelop this area over a long period of time. So this is just to give you a sense of the types of lectures that we'll be seeing. Again, this is subject to change. But I do want to highlight that there is an extra credit lecture in the fourth week on Tuesday from 12:30 to 2, which is your exam hour. All of you are available at that time. The extra credit that's associated with this will be announced during this lecture, but it is given by one of our writing consultants who's been with us for a while, and he gives you specific tips on what to do with your writing when you're writing your lab reports. So I highly recommend that you make it to this, this extra credit lecture. Again, the rules for this lecture: make sure you keep your laptops closed. So there's no using cell phones in this class, and no talking. We bring in people from other industries, we bring in people from different departments. We want you to be respectful of what they have to say. They're all experts. Try and get as much as you can from each of the individual lectures to get to know what their perspective is on the field of engineering. And the slides will be available at the end of lectures for the majority of them. A few of them present content that is either copyrighted or prohibited for us to share. But we share the lectures so that you have them to review when you go into the next week's lab and take that lab quiz. Are there any questions at this point about lecture? Yeah. So you're asking, are the slides going to be available prior to the lecture starting?
I'm asking whether we can be informed of
The one that I'll just warn you ahead of time is the last lecture. The World Trade Center project has some information that shouldn't be published for free online. Okay? Any other questions? Yeah.
So the lab from the lecture,
Lab 2's quiz will include some information from these slides today. So, easiest thing to do, again, before you go into lab, download the slides and make sure you review what went on in the lecture the week before. Anything else? Okay. So for the labs, there are 9 labs in total. 4 are focused on building your skills. 5 are focused on design competitions. They're designed specifically to be able to account for the variety of engineering disciplines that are here at Tannen, as well as some of the new technologies that you'll be using, both in this course as well as other courses. The labs are going to be made up of these 9 labs. So just to give you a quick run through, the goal of the product dissection lab was to introduce you to the engineering design process. We wanted to give you a chance to think about how would you go about designing a water toy, and then how could you use available information from other products to make improvements with your design. I personally encourage you, if you enjoyed dissecting the products, download SolidWorks eDrawings Viewer. It's free and it's available for Mac and Windows. Look at all of the different parts, and you can incorporate those into your lab report. One thing that you'll be expected to do in your lab report, as you're including data about the different functional characteristics of the product that you dissected, take screenshots from the eDrawings viewer of the parts that you dissected. So if you're looking at the power drill and you're looking at the power source being the battery pack, isolate that and use that as a figure in your lab report when you submit it next week. The next lab you're going to be doing is boom construction. So similar to a bridge design competition, you'll be building a boom that can hold the most weight possible. It's a very fun lab, team-oriented and competition-related. The reason I've denoted which labs are competition labs, if you come in first or second place for any of the competition labs, you will be getting extra credit. So it's a little incentive for you to think a little more in-depth about the design that you're completing and what your objectives are for that particular lab. In the third lab, you'll be introduced to LEGO Mindstorms and how to use sensors for automating certain products. So you'll have an exposure to robotics. Everybody will learn how to actually program using some basic programming logic. In the fourth lab, iterative design, you're going to be doing two things. One, you're going to be getting a part that is a structural mechanical part, and you need to redesign it in order to make it as strong as possible. And then the other half of it, you're going to be designing your own apartment or dorm room in Autodesk Revit. So you'll be using two different Autodesk packages, which is a company that develops CAD software, both Fusion 360, which you'll see in this week's lab, as well as Revit, which is used for architectural and construction design. In the fifth lab, you're going to be designing a thermal insulator, as well as an Arduino circuit to be able to track the temperature that your thermal insulator is able to keep the material at. So 4 competition labs in a row. Then you'll be introduced to LabVIEW, which is a software package for mechanical and electrical controls. Digital logic, to understand the basics of circuitry, as well as how digital logic is actually processed using integrated circuits. And then 2 kind of fun labs at the end, a sustainable energy vehicle. So you'll be using solar, wind, or hydroelectric to power a vehicle and run it in a competition. And then biomedical forensics, where you're going to be using scientific tools to be able to find the murderer in a mock scenario. And then in recitations, this is when it's going to be your chance to present. So you'll be giving short presentations each week and giving feedback on your technical presentation skills, as well as how to become a better public speaker. The lab reports and presentations might feel a little bit repetitive, but think about this like a sport or a musical instrument. The only way you're going to get better at it is if you do it over and over. And the recitation TAs, the recitation professors are in the room as a coach, as well as the writing consultants, to coach you through that process and make improvements throughout the entire semester. So, the semester project. To give you a heads up of what you're going to be seeing next week when we go in depth about what you're going to be doing in each of the projects. The purpose of this project is to introduce you to engineering project management. So we're just exposing you to the basic fundamentals, including Microsoft Project, which is scheduling software. So taking you from the very first days of working on the project, where you're brainstorming, to the very end, where you're actually commissioning and turning in your deliverables for the project. You're also going to be tracking your budget, and both of these are going to be things where you're going to be learning in the real world how to do this as you gain experience, but we want to give you some preliminary experience here just so you understand the fundamentals before you go out and do this in the real world. In the middle and throughout the semester, we want you to focus on component testing. This is a really critical part of the engineering design process where you actually test and reevaluate how something works and then make improvements as you can. So the deliverables at the end of the semester will include a variety of things, including your CAD drawings, your schedules, your budgets, and just a general understanding, your final presentations of what you did the entire semester. The 4 main sectors of projects that you can do include the Rapid Assembly and Design Challenge, which Kaylee will go into detail about, as well as the biomedical devices, which is very closely related to RAD. And then NYU Housing and Innovation in Revit, you have the option to expand on the ideas of building your own apartment or dorm in Lab 4 to design an entire building for Brooklyn's NYU campus. And then the Autonomous Robot Project. So you'll be selecting one of these. The Autonomous Robot Projects, you'll be using LEGO Mindstorms, where you click one button and then the robot needs to be able to complete an entire obstacle course without any intervention. So the 4 robot projects, which you'll see in the model shop next week, are the bomb disarming robot, the retrieval and delivery robot, search and recovery robot, and Mars rover. So simulating a variety of real-life scenarios, including delivering a bomb, or disarming a bomb, retrieval and delivery of fuel cells in the case of a blackout, which hopefully Hurricane Dorian doesn't make its way up to New York and we see another Sandy. Search and recovery in Mars rover are the lunar surface and the Martian surface, to give you a sense. So on the left is an example CAD drawing of one of the robot obstacle courses that we created. This is the bomb disarming robot. And then down here in the bottom right, we've got the Housing and Innovation in Revit, one of the award winners. One thing to keep in mind, we do award through what's called the Nick Russo Award. You saw this at Convocation for the students who were last year. The people that do the most innovative designs for their projects have the opportunity to be nominated for this, and then for each individual project, we select a top or winner, and you get invited back to Convocation the next year and a small little monetary prize. So this was the Nick Russo Award winner for the Housing and Innovation in Revit because of their use of green landscape architecture and a variety of other energy-saving techniques. And Haley will go into more detail about this, but again, the Rapid Assembly and Design Challenge is to get you thinking about what are some of the real-world problems that need to be solved by engineers. And some of the examples here in the past include things from prosthetics to even holographic toys. And the biomedical devices is a subset where we've seen a lot of people create prosthetics and wearable technology. And if that's something that interests you, then you can focus on the biomedical device applications that Caleb will expand on in a minute. All right, so just to introduce you to engineering, you've had a little bit of discussion in recitation, but what really is engineering all about? So I think some of the things that came up a lot in our recitation, everybody agrees engineering is about problem solving. Engineering is about applying mathematical and scientific principles to real-world situations. And it's about critical thinking so that you can work towards ingenuity. And this idea that we, as engineers, we have a strong emphasis on making sure that we have technical excellence for everything that we design. So there's a lot that goes into the engineering design process in terms of research, looking at the right materials and resources that we need to execute a design, and then also paying attention to the costs and schedules. As engineers, if we could over-design everything, we would, but we're always constrained in the real world by the money that it takes to get something done and the time that it takes to get something done. But in the end, engineers are the ones who make the world go. So we're the ones who, when the Stern business students come up with a great, innovative idea, they turn to us to say, how do I actually make this happen? I had this idea, but I didn't know how to get it anywhere. Us as engineers, we need to be able to take any of those types of problems and then translate it into the real world. So why is engineering fun? It should be about being altruistic. Being able to serve others. So everything that we do in engineering has an impact on society. And the better impacts that we can have in terms of the things that we design, the opportunities that we create for other people, or the technologies that we create in order to solve problems, is really what engineering is all about. We want to be able to create new capabilities, but we also want to be able to do it so that we can save money. Ultimately, if you have a great idea, like I talked about in recitation, number one, you need to be able to communicate that idea. But number two, you need to be able to make it feasible. So financially, you need to be able to save money to make a product or a service available on the market. And then as engineers, you should be excited about the opportunity to create. Hopefully we can get you at the point, even if you're comfortable now, feeling like you want to go into the makerspace, if you're not, go into the EG prototyping lab. We want to get you comfortable so that you can walk into the makerspace and start creating your own ideas, whatever it may be. And that, at the end of the semester, you can actually look at something that you've done, something that you've created, and you can feel proud about it being yours. As well as a team, being able to work together to work towards one shared vision or one common goal. You all get to appreciate the credit and the outcome of the project that you were able to work on. And We know for a fact that these skills are desperately needed. So, the technical skills, we need people that have analytical thinking skills, not just in the field of engineering, but every employer out there is looking for these sets of skills. So we want to get you on the right start to be able to be successful using design and analytical thinking skills to be able to solve problems. Because when you go out into the real world, you will have a supervisor or somebody who's working over you to give you instruction, give you guidance about the way things are done at that company, the way that the resources that you'll need, or the handbook that you'll need to complete some sort of design. But the more that you can do these things independently, the more that you can approach a brand new problem and think about how am I going to solve this uniquely, the better off you'll be in applying your technical skills. We can't hit on enough how important communication is when you're working with people on a large team, when you're communicating to your supervisor what you've accomplished, or when you're communicating to people who are funding your project, where you are in your project. Being able to do this both through a written report, or a memo, or an email, or verbally being able to present, having a presentation or a poster, and being able to explain exactly what you've done. And you need to be able to both hit an extremely technical audience. So if you're working with a group of engineers, you need to be able to explain all of those details using the correct terminology. Or if you're working with people who are just investors and don't know anything about the technical background or skills that go into the project, you need to be able to reach a large audience as well. Teamwork is essentially getting everything done. We'll talk about this in 2 weeks in lecture. But teamwork is really the way that any engineering project is completed now. If you look at the companies that are doing the most exciting and interesting things in engineering, the way that they're capable of solving these major societal problems is through teamwork. And then, of course, like I just mentioned, in order to make it actually an effective solution, you've got to think about the business side of it. It needs to be able to make money in the long term. So, the other thing I want to really to ask you is, do you really know what engineering is? Some of you might have had some introduction to engineering courses in high school. You might have done an intro to a programming course, or you might have looked into all of the different departments here at Tandon. But do you really know what engineering is? So we want this course to be a survey course where you see a little bit about each of the different disciplines and reevaluate, is the area that you are currently studying in, or the area that you currently declared a major in, the thing that you want to be studying for the next 4 years. After taking this course, around 10 to 20% each semester report that this course helped students make a decision about what they wanted to be, or if they're undeclared, or actually change their major. So keep that in mind. You're not stuck in any decision that you've currently made. There is flexibility about switching around. And this first year is really the best time to make that decision before you've taken too many courses that sets you off the right trajectory to graduate in 4 years. It also gives you a hands-on experience. In a lot of classes, you're going to be doing kind of traditional homework assignments as well as exams. This class is focused on giving you a chance to actually interact with the technology you're going to be working with, to actually build the Arduino circuits, to program them on the computers, to design things in CAD software, print it out. And hopefully, in that way, this course is very engaging and interesting, a little bit more fun than the lab sessions. But also, there's a strong need to develop these badly needed skills that employers have come to us about. This table comes from a report that Siemens, one of the largest engineering firms in Europe, created. They basically looked at and surveyed a variety of companies to see what are the primary experiences that they found that students had that made them a better employee. So the main things that they talked about by percentages were team-based projects that simulated the real-world corporate structure. And here, of course, we only have 3 or 4 people per team. But still, think about your team as a small little startup company. Projects that include designing and analyzing, testing, and building. That's what you're going to be doing this entire semester through the SLDPs. And then competitions that solve real-world problems. So for those of you who are interested in the Rapid Assembly and Design Challenge, this is a chance for you to work on a real-world problem and then also put that on your resume. So when you go to talk to employers, you can talk about an experience that you had solving something to do with sustainability or something to do with biomedical problems. Working with teams that have a technical focus, but also people that are outside of engineering. So there are a few majors in here that at Tandon that are outside of the areas of engineering. And there are also some people that have chosen to take EG 1003 that aren't at Tandon. So get to know them, talk to them, especially if they join your team, and take advantage of the different ideas and backgrounds and perspectives that they have. And then also working on multidisciplinary projects. So as much as we can throughout the semester, we want you to be working with people from different disciplines. So what other skills are employers looking for? They want people who can do design. They want you to be able to think about how to choose from multiple alternatives. So whenever you're solving a problem, the typical solution doesn't just go from point A to point B. There are several different steps along the way, and they want you to be able to identify, here are the different ways I can solve it, and then justify why you selected your specific route for your design and your problem solution. They also want an ability to manipulate data. Data analytics is critical, as well as equipment. So we introduce you to LabVIEW so you understand the basic functions that go into the logic for controls, as well as Arduino, which has a cheap way of adding connectivity to any device, any everyday ordinary device that you use. They also expect your ability to present and your ability to write technically. That's why the writing consultants are in your class to give you specific feedback to make sure you make improvements through your writing throughout the semester. Your ability to work in teams, and then the business skills that are labeled below. So another group that looked into employers and trying to find out what employers really want is the World Economic Forum. This came in a report called 2020, The Future of Jobs. And when you compare the skills and demands between 2018 and 2022, there's a number of changes that we're going to see. Now, declining here does not mean that these skills are not important. It just means that they're less important than some of the emerging skills that employers are looking for. But they are things that you would predict, like manual dexterity, memory, those types of things, and now that we're dealing with artificial intelligence and machine learning, aren't as critical as they used to be in the workforce. What they are looking for are analytical thinking skills, complex problem-solving skills, and critical thinking, the things that we want you to accumulate throughout this semester. In addition to that, there also is a big need right now for emotional intelligence and leadership in engineering. We want people to leave after they graduate here and go into the workforce ready to be able to lead any projects that they're working on, as well as have the emotional intelligence to deal with the variety of personalities and people that you'll have to run with. This semester, you might run into issues while you're working on a team, but the ability to work through that and having experience with that is what's going to help you set you on the right path for success after you graduate. So with engineering, there's also a large emphasis on quality. And that means we want you to be able to do the best that you can and get it right. Employers, eventually when you go out and work on a project, don't care about whether or not there was any partial credit that you can earn for a homework assignment or an exam question. They want to know whether or not what you delivered to the customer is what they actually wanted. Is it something that they can actually use? And was it quality enough to meet their expectations? So this also includes repeatability, which is something that's critical for the engineering design and analysis process. Any scientific work that's done needs to be repeatable. You might complain about why you have to write in a passive voice, but as the writing consultants have told you this week, it's about being objective. It's about not the fact that you did this particular or you worked on this particular problem and you came up with this particular solution. It's that any engineer who approached the same problem in the same way would have derived the same solution. So repeatability is really critical, and we want to give you some objective metrics to understand how this works. That's why there is a rubric for the writing consultant portion of your grade. There's a rubric for the TA portion of your grade as well, and we expect you to be reviewing those and continually make improvements throughout the semester. So, to be successful in this course, take advantage of all of the resources on the lab manual. There are a number of how-to guides for a variety of the questions that you might have. There are sample labs and presentations you can take a look at to get an idea of our expectations before next week when you're completing your first lab report, or in 2 weeks when you're completing your first presentation. And you might be wondering, how do I know if I'm doing this right? So you'll be getting feedback from the writing consultants, you'll be getting feedback from the recitation TAs and professors. Make sure you're incorporating that feedback every week as you're going back to work on your next assignment. Use the lab manual. In addition to the how-to pages, all of the write-ups for the projects and the lab assignments are there to guide you through the process of developing your reports, developing your presentations. And then assessment at the end of the term, you can get a kind of collective look at how you performed and how you grew throughout the semester. So, but what should you do more importantly? We hope you have a lot of fun in this course. There's a lot of hands-on activities that you can get involved in. There's a lot of people that you get to meet, both the TAs and the other students that are in your class. Use the mentors, the TAs, as a chance to learn about all different aspects of engineering. A lot of them have gone through similar situations to what you're going through right now. They might have come in as undeclared, or they might have come in as a specific major, or maybe they're a transfer student. And there are enough TAs that somebody probably matches what you're going through right now. So try and find them, talk to them, and see if they have any advice about what you should be doing or what you should be thinking about. And the goal is that the skills that you'll develop over this semester, those professional skills, are something that will last you a lifetime, something that you'll continually work at and continually develop. But they're also critical for your success here over the next 4 years of Tandon. So, I know you have a lot of this material in recitation, but we wanted to just kind of round everything out so that you have a good perspective of what you are doing in this course, what the expectations are for this lecture. Before I hand over to Kaylee, do we have any other questions about EG 1003 or what the expectations are for this semester? Yeah. So the workshops are intended to do 2 things. One, prepare you for those skills so you can actually apply them directly to your projects. So even more so than the labs, they're specifically designed to help with the project assignment. But yes, we do see that people that attend the workshops are in the makerspace in the workshop by itself. But we want you to be going into the makerspace on a regular basis, even in this course. As part of the Lab 4 pre-lab that you'll be doing, all of you will have to go to the makerspace to get the basic lab safety training. That will give you access to be able to use the Ultimaker 3D printers for free in the makerspace. So that is a built-in part of this course that you'll have to go do regardless. But we do encourage you to use all of the resources in the makerspace, including things like the laser cutter and the CNC machines. But all of our resources in the EG prototyping lab are also free for you to use. And there's a TA there to help you figure out how to use 2 colors to print when you're doing the NYU keychain and you need to get white and purple. There's TAs in there to help you figure out how you actually go about soldering or desoldering some sensor that you're trying to develop. Does that answer your question? Okay. Yeah. The prototyping lab is in between the 2, Lab 1 and Lab 2, which, if I go all the way back, between 574 and 576. And If you go into lab 1 or lab 2, you can just walk around the corner and go into the prototyping lab. If you're also confused, you can go to the model shop. There'll be a TA in there who can escort you over to the prototyping lab and direct you there. Another question? The timings for the workshops is the question. They will be posted as an announcement soon. They're being finalized between, we wanted to make sure that they didn't overlap with any exams or courses that you're likely to be in. And then we're confirming those will be the makerspace. We will most likely have them posted as Eventbrite where you'll register to be connected to it. Any other questions? Okay, so you're welcome. Kaylee to the stage. She'll go over the rapid.
Amazing. So hi everyone, I am Kaylee Dunnigan. I'm a 4th year chemical engineering student, so I am graduating soon. Who here's a chemical engineer? CVE. Woo! We are average for engineers. Yeah. So I'm also the head of research and development here at the general engineering department. There's a lot of TAs. The TAs can take different roles. So I help, along with a few others, develop the labs and the semester-long design projects. The two that I'm going to be talking about today is the rapid assembly and design project and the biomedical project. Those ones are going to be slightly newer, more exciting options that we have here for you guys. There's lots of TAs to help you throughout the semester for these projects. Some of them are in the back. If you guys want to look back there, ooh, we all have high school diplomas, so you know we're smart. And again, EG 1003, there's a lot of different skills you're going to be developing while you're going to be working through these semester-long design projects. Some of them are going to be professional skills. I know the professional skills can seem kind of silly at times, but they're really important. They're going to be continuing throughout your education. Just yesterday, I got a presentation on how to write a lab report, despite I've been writing lab reports in high school. It's still a skill that I need to be developing. This summer, I was at Cornell, and they gave me a presentation on how to give presentations, which again is also something that I had to do in EG 1003, and I also got a presentation on how to give presentations in EG 1003, so it doesn't end. TAs are here to help you learn these things. I want to teach you guys just a really quick, fun professional skill. It's particularly for the ladies. I have a little microphone right here. Men's shirts button the opposite way as women's shirts. And so the microphone clip is in the direction for men's shirts. So when you're a woman and you're giving a presentation, you take the little clip, you rip it off, you flip it, and then it clips to your shirt. And then when you're done giving the presentation, you leave it that way, so when a man comes up and gives a presentation, it is really irritating for them because it just doesn't sit right. We're going to be going over some of our more exciting projects. These projects are supposed to be very interdisciplinary, team collaboration. The goal of these projects are to create really interesting functioning prototypes that are amazing for your resume development. It's amazing also just for your professional development in general because you're learning a lot of skills. And EG 1003 is great because you learn a lot of skills that are outside your major. As a chemical engineer, I won't learn Arduino in any of my classes, but Arduino is a great thing for all engineers to learn. I learned LabVIEW EG 1003. I had to use LabVIEW this summer. You know, my postdoc came up to me and asked me if I could do it, and I was like, yeah, I know how to do that. Like, I'm fine. So like these skills are important to all of us, and so it's great to really be an interdisciplinary team. So if you're doing a project that's like kind of off from your major, it's still really great for your professional development. So these new projects that you guys have the opportunity to participate in, as opposed to the LEGO robotics projects, really focus on the problems that we're facing in the world today. The UN has 17 problems that they think that everyone, including scientists and engineers, should work together to solve. Can you guys name a few other problems beyond the ones up here that you're particularly interested in? They can be world problems, they can be personal problems. Anyone?
Rate inflation at Camden.
Rate inflation at Camden? Not enough rate inflation. Yes. Amazing. Anyone else? Yes. Tangent Camden's in Brooklyn, also a world problem, yes.
That's a 550 round trip for this story.
So 550 round trips. Use those free buses. They run till like 10 p.m. now.
Exactly.
Anyone else? More world problems? Environmentalism? Anything? Yes.
The Amazon is on fire.
The Amazon's on fire. That is a world problem. Also, part of Russia is on fire, so the world is just burning right now. Yes. Amazon, the company, is not paying taxes. Also a world problem. That is involved with ethics. Yes. The MTA is delayed a lot. Yeah. That's irritating. Yes.
Less here, but also there's literally genocide going on right now in both places in like South Africa and in China, so stay woke.
So stay woke. Massive amounts of genocide. Environmental issues. Yes.
Every year here, our tuition goes up when my scholarship doesn't expand.
Okay, some of these are a little bit more relevant than others, but they're all great ideas. So we're hoping to offer you guys a free choice open-ended design project that we name Rapid Assembly Design, so you can call it RAD. And we're hoping you guys can come up with creative solutions for world problems, personal problems, anything that could potentially be marketable. So these are things that you could be interested in, or maybe that the application you aren't really interested in, but the design software that you're using you're interested in. So you're using your own ideas to come up with a project and problem statement, as opposed to our predefined problems and our predefined projects where the statement and the solution has already come up for you. Like the robotics projects, you're starting at the beginning of the course and you're working all the way till the end of the course. With these RAD projects, you get to define your own problem statement and your own solution, and you get to make your own innovative prototype that's going to be yours at the end of the semester. And it's something that you can really call your own and something that you made all on your own or with your team. These projects and the development of these projects is you're going to get a small stipend to work on them. You're going to receive a mentor that you're going to meet with weekly. You have all of our other TAs. We're going to have 3 TAs for you for 8 hours a day in the model shop and 4 hours a day on the weekend. So there's plenty of time for you to go in and seek one-on-one help. If you feel like you don't know a lot of engineering skills yet, like if you don't know what Arduino is, if you're not comfortable at all with coding, if you don't know any manufacturing techniques, if you barely know CAD modeling and your very first time CAD modeling was this week in lab, that's okay. These TAs are here for you, and they're here for you a lot of hours of the week. It is noon to 8 p.m. on weekdays, and I think noon to 4 on weekends. And again, there's a lot of TAs for you. And you're also going to have to meet with one weekly. We also have a ton of other supplies that are going to be for free, not coming out of that small stipend we gave you. And there's a lot of other resources in the school that we're going to provide for you. We also created an online library to help you get started in your research on these projects, as well as a lot of other resources that EG has to offer, such as the prototyping room and our workshops. So if you don't feel comfortable with engineering, if you have an idea, or you have a team and you know you want to do this project, but you don't feel comfortable with your engineering skills yet, that's totally fine. We are here to teach you the skills. All of our wonderful TAs are here to teach you those skills. We're just going to be going over a few of the projects that have been done in the past, just to kind of see what other students have done. And again, these are students coming in with no technical knowledge, and maybe not even a fully formed idea, just a part of an idea. Or some of them don't even have an idea, and they work with someone who's a little bit more creative with them than them, and they work together to come up with something amazing. So this is one of our previous projects, Pepper Pet. It's a holographic digital pet. It's interactive. They had like a little system that you could input short answers, and then the little animal would move and interact and talk with them. This is Speak Sign. It's a glove with colored dots on it. Their computer would track the movement of their hand, and it would translate sign language into written and verbal text. This is Oho. It would translate, it's a little VR tech you put your phone on, and it translates normal text into a dyslexia-friendly font so that it's easier to read. Helping Hand is one of the prosthetics that a group came up with. RAD will no longer be accepting prosthetic pieces and wearable pieces because instead we now have the biomedical project. We'll be hosting only 5 to 7 of these projects this semester because it's a new semester-long design project for us. There'll be 4 options, 2 of which are prosthetics and 2 of which are wearables, so you do have a little bit of freedom in what kind of project you're creating. It's not as open-ended as the RAD projects are, but they're not as limiting as the LEGO robotics projects are. So you could be developing a prosthetic just like this or potentially a wearable. So those are some of our projects from last fall. These are some of our projects from the spring. The top right tracks if anything is stolen within a room. It tracks what is there previously and then monitors the room closely to see if any important and expensive objects are left. The next one over, Terra, it simulates weather inside of a room, so whatever the weather is outside, it's also in this cute little box. So if it's raining, it'll also be raining in the box if there's thunderstorms, or if the sun is rising, etc. The next one over, it's a navigation system for the blind. It can help you navigate through the city. Below that is a spectroscopy instrument that will analyze a food sample and tell you if there's an allergen within the food sample. The next one over, it's a close-up view of glass fiber manufactured foldable skis. And then on the far bottom right is DOT. It translates words into Braille. That's the word, amazing. It translates words into Braille. So these are all really amazing technologies that students developed with their team on a small stipend, with a mentor, and with the resources that we provided them. So in order to show your interest in RAD and show your interest particularly in the biomedical projects, and again, the biomedical projects are different than RAD. You will not be receiving a stipend. You will be receiving a small kit of a variety of materials, sensors, Arduino, and there's a few other materials that you can request if they're needed. But it is a different project than RAD. You will be limited by the materials. That's going to be a big thing in developing a wearable or a prosthetic. Wearables are just something that reads your health and gives you some kind of output, or it's some kind of technology that's integrated into your clothing in some way. And so if you want to do the biomedical projects, those will kind of be your range of options. Again, it's more limited than RAD, but more open than the LEGO design projects in terms of creativity. So you guys, right now, one-time offer, you can take out your phones and laptops. Please fill out this form. This form is going to help us determine how many RAD projects get assigned to your section. It'll also help us determine how many biomedical projects are assigned to your section. So if all 15 people in your class want to do RAD, you'll be assigned a lot of projects. If only one person in your class wants to do RAD, you'll probably be assigned 0 or maybe 1 RAD project. So it's important that you fill it out, and it's important that you have the right section. If you fill it out to the wrong section, you're giving that section your votes, basically. Because we will have limited RAD projects. There's also a link at the beginning of the form that gives you detailed descriptions of every project, if you don't remember what these projects are. Please let me know if you have any questions. Fill this out. We'll be closing the survey at the end of Friday, and then your class will be stuck with the number of RAD and biomedical projects.
But 1 second, if everybody can stay quiet, we have a question in the back.
Just curious, like for RAD, is it one of the reasons like you can only work with other people in the class, or someone out this time?
So for all of the projects in EG 1003, you're going to be working with the people that are in your recitation and lab sections. So this survey is used as a tool to allocate the number of RAD projects per individual sections. Any other questions? Yep.
Can I work with like the people in the other two sections?
So this is specific to your actual recitation or lab section. So if you're in D2, then you can only work with the students in D2.
Okay.
Groups will be formed based around the lab and recitation section. RAD? Okay, the semester-long design project is a mandatory portion of the course. Which project you do is up to you. Everybody's going to be doing a project. This is not binding. This is to decide where the RAD projects will exist in the course.
Yeah, what you write right now is not what project you have to do or what project you will do. We're just gauging interest in order to distribute the number of RAD projects because there's limited projects. Okay. Is there any questions related to RAD?
Okay. It sounds like we're wrapping up. So one last thing. Everybody, pay attention. We have one more question over here.
For RAD in general,
For RAD, everybody, if you can settle down, we'll let you go in just a second. The question was, do people need to have prior experience? And the answer is no. But if you do have prior experience, there's nothing wrong with bringing that to the table for completing the RAD project. So keep that in mind. We're here to provide the support that you need. The last thing I want to mention, remember every day we're going to be in lecture from 12:45 to 1:45. So be here on time. Make sure you're getting here on time. And the TAs in the back of the auditorium back here, if you raise your hands again. Everybody, quiet down right now. All right? The TAs in this auditorium and the TAs in the rest of the class, you should treat with the respect of a faculty member. So if they come and tell you to put a phone away or they come to tell you to put a laptop away, make sure you're listening to them throughout the entire semester, both in lecture, lab, and recitation. So have a great day. Make sure you fill out that survey. Thank you for a good first
Your entire city.
Go to Zach. You will be? Will be. Yeah, we're going down. Let's see that.
I sent a request to see your calendar because I want you to match up with like all this week.
Oh, okay.
So eventually, I may want to interview us actually. So then when I go back to analysis and we can talk about it, I'm just making papers and presentations. So, yeah.
All right. Really my schedule Tuesday, Wednesday afternoons work very well. Monday and Friday work well, but more for the stuff those companies. Not there. There's just that lecture.
But
Tuesday, Wednesday is the best. Monday and Friday is second best. Afternoons are always preferable to the
I'll shoot for Tuesday. I'll talk.
Okay, look forward to
See you later.
You have a question? Yeah. So I know that I've read about people working on this. I think it's a great idea for the project. I think one thing I didn't mention today, but I mentioned in the future, we'll guide you through like that idea is a great start, and then we'll guide you through what's feasible to do in 10 to 12 weeks or whatever we go through. So it might be that you kind of like prototype an aspect of it, or you start thinking about maybe doing a large scale version of it. But we'll have to think about it, and then once the RAD teams are assigned to sections, those RAD teams themselves that form will apply, and they'll submit their ideas. And we'll ask to submit 3 ideas, so it depends on what we think is the most feasible. So maybe doing a little bit of research before you submit that application of the idea of exactly what the other activities. That's the only thing to think about, but I like the idea that you're thinking. And just so you know, we have a number of augmented reality and virtual reality projects that are going on with this. So it might stem from something like that initially, which you could focus on the development of augmented contact who, like who?
Somebody that you know, like, or like,
so this is one of the things we want to challenge you to do a little research on your own first, and then the mentors will really join you after the team problems are formed. But feel free to talk to the faculty, TAs. I think it's an interesting concept. I think you're going to need to think about what can you do, what can you prototype in a semester that will lead towards that, because it's not going to be the full thing.
yeah, I understand.
Hey, any other issues come up? Everything worked out well. We've got everybody scanned in.
Only one of us.
Yeah, that's your.
See my wallet?
Your water?
My wallet.
Wallet? No.
Yeah.
I dropped it somewhere.
Like, you know that for a fact?
I mean, I walked in with it. I couldn't walk in without my wallet.
Check, like, keep opening these.
It would fall through if you're open.
I don't know, but like, still. Is there anything in there you can track?
My ID, my brother's wallet.
text me also to see somebody pick it up for you because you lost it. Texted me. SCG. SCG. I thought I didn't have it.